looking at my attempt to build an X-Class monster-size FPV drone using woefully underpowered mini-quad electronics, a seriously questionable foam frame, and 3D printed reduction gears designed to spin the way too large 18-inch propellers. The crazy thing is, it actually kind of worked.
Watch what happens.
Okay, now that you've seen the end result, let me back up and explain just what the heck is going on here. Hey everybody, welcome back to RCwithAdam. This is a common FPV drone, or a mini-quad as we call it in the biz. This thing spins 5-inch diameter propellers and has a carbon fiber frame just big enough to fit everything. This is an X-Class racing drone. It's freaking huge. And this is the sponsor for today's video, PCBWay. They make custom printed circuit boards and electronic parts. So if you're working on an electronics project and you have a circuit board that you've designed, you can upload that file to them and have them build that circuit board for you. And they can even assemble all of the components on there and then send it back to you as like a ready-made package, which is pretty cool. But they also offer rapid prototyping services, so you can get something injection molded or sheet metal cut or CNC machined or 3D printed. And as you'll see later in this video, if I didn't have a 3D printer, this could have been a good option. So if you need some prototype parts, but you don't have any of the tools or machinery to make it yourself, you might want to check out PCBWay. X-Class drones are basically just a supersized version, often with 10-inch or larger props with a 1 meter wide frame, which is awesome. But big props and a big frame means you'll need some big, powerful motors, which means you'll need some big, high amperage ESCs, and all of that means you'll need some big money. Just one motor can cost around $120. Naturally, upon realizing such high-performance, top-notch components are required to build even a halfway decent X-Class rig, I decided instead to use parts intended for a tiny 5-inch FPV drone paired with some random 18-inch carbon fiber propellers I had laying around. I mean, what could go wrong? Now the first problem is that these props are about 3 times too big and heavy for these tiny little motors. And these motors are made to rotate at about 4 times faster than what the propellers are intended for. If I attach the props directly to the motors would burn up. This is where the 3D printing comes in. I need a way to increase the torque of the motor while decreasing the speed of the spinning propeller. So I started designing a simple 4-to-1 reduction gear system. Okay, well, my first design was not so simple or robust. I tried using an idler gear, which would keep the propeller's axis in line with the motor and allow it to spin in the same direction as the motor. This is kind of cool, but ultimately was larger than what I needed it to be and failed due to way too much slop in the gear set and overheating in the center, which melted the gears together. So yeah, that was a no-go.
So this one didn't work out super great.
Next, I went with a more traditional 2-gear design. The drive gear on the motor has 12 teeth and the large gear has 48 teeth, giving us that 1-to-4 reduction. After testing a few variations and improvements to the base, gears, and propeller adapter mount, I finally had a viable gear reduction assembly for the motor and propeller. Static tests showed that the assembly was strong enough to withstand long periods at 50% throttle, pulling only around 10 amps, and I estimated that during actual flight, each motor would probably only need about 15% throttle to maintain a hover, so the amperage draw would be way less than 10 amps in actual flight. That's the idea anyway. All I need to do now is print 3 more and assemble them. All of these parts are printed on my CR10 or Ender 3 printers using 3D Fuel Pro PLA filament. But now, of course, I need something upon which to slap all of these components. This is where the highly questionable frame comes in. I thought, well, since the motor assembly is so lightweight, and also laughably sketchy, the frame should really match. So, partly out of curiosity and partly to pay tribute to all the foam airplane builders out there, I decided to use some Adam's Ready Board and insulation foam to build this frame. It measures about 40 inches or 1,016 millimeters diagonally, motor to motor. And yeah, I didn't think this was the greatest idea either, but I kind of wanted to see if it could be done, and you know, once you get an idea, you gotta try it out. So that's what we're going with. The motors I'm using are Emax Eco 2 2207 1800 kV. And the flight stack is a 20x20 iFlight Success E Mini F7 with a 35 amp 4-in-1 ESC. And yes, these electronics are laughably tiny, but that's also keeping with the theme. To mount the electronics, I hot glued the bottom plate from a Source 1 frame to the center of our gigantic frame. To extend the motor wires, I used sections of an old extension cord from, I think, an old vacuum. So yeah, only the best for this build. With this monstrosity finally assembled, gears lubed, and final safety checks, it's time for a real deal hover test out in the wild. And yes, I'm using that overturned metal table to protect me in case this thing explodes. As you can see, it's having a difficult time hovering and is mostly uncontrollable. I'm guessing this is due to the massive amount of vibration coming from the gears, which resonates through the extremely floppy arms. It's also worth noting that the default Betaflight settings for this flight controller are intended for small 5-inch quads, and I have not made any changes because honestly, I'm not really sure where to start. So yeah, I know this I wasn't really setting myself up for success.
Alright, so there's a lot of weird stuff going on. Back to the drawing board. Oh, I mean, overall, it does sort of fly. So in terms of like that part working, it kind of works. It's just a matter of getting the fine details tuned.
And yes, I realize that's a pretty big problem. However, I thought the bigger problem is probably these arms that are flopping all over the place. So if I can get those stabilized and get the frame more rigid and less vibration-y overall, then we'd be in a better starting point to start making changes to the flight controller. I knew the arms needed to be stiffened for sure, so later I added some braces between the arms. This improved the rigidity and durability tremendously, but I'm not sure it helped with the actual flight characteristics. I was still having what appeared to be a runaway PID loop situation where the flight controller will try to make corrections to the point where the quad just flies away on its own, and if you let it. Also, it seemed to be very unstable about its diagonal axis.
Whoa, okay, that almost worked, but how are these motors doing? Oh, shoot. Oh my gosh, those motors are hot. Okay, wow, yeah, that's a hot motor.
Later, I did a few hover attempts while logging the Blackbox data. Here's the result of that data. Let me know if this makes any sense to you. To me, it just says, "Congratulations, your drone is a piece of trash and your flight controller is very unhappy." So if you have some tips or suggestions for getting this thing under control, let me know. Leave a comment or even email me at rcwithadam@gmail.com. Wow. At this point, I needed to start working on another project, and I kind of needed to take the electronics from this project, so I decided to mothball this one for now. Also, I was having some issues keeping the propellers on tight. Although most of the propellers were staying on pretty well, a few of them were not, and it really was not a very sustainable, safe option. So I figured the next time I do it, I'll make improvements to the propeller mounting system as well. At this point, you might be thinking, well, gee, what a disappointing waste of time and money. Time to give up on life. And to be honest, I kind of thought that too. But not so fast. Because while I didn't achieve my initial goal, at least yet, of building a cheap and ridiculous XClass sized drone, I haven't walked away empty-handed. I got a lot of practice designing 3D printable parts in Fusion 360, like hours and hours and hours. And I got to experiment with 3D printed gearing, and I learned that foam is not an ideal frame material for a huge drone. I mean, I guess I already knew that one, but at least I confirmed it. I did successfully create a functioning, albeit not very well, prototype of my initial idea, and now I have a gear reduction system that I'll probably use as a standalone part for a super sweet airplane build. And most importantly, I took action and brought to life an idea that had previously existed only in my mind, and it became a reality. And I think that's pretty neat. So keep creating, keep flying. Also, if you're interested in this 3D printable gear assembly, I'll probably have that available on my website by the time this video comes out. So check for a link to that in the description down below. Thanks for watching, and I'll catch you on the next one.